Main components of room. Using room, you need tables to store the data and queries to access and modify the data. The following three components of room makes this workflows seamless. The database class that holds the database and serves as the main access point for your app's data. The data entities that represents table in your app's database, and those data access objects that provide methods your app can use to query, update, insert, and delete data in the database. The database class provides your app with instance of the DAO associated with the database, and the app can use the DAOs to retrieve data from the database as instance of the associated data entity object. The app can also use the defined data entities to update, insert, or delete rows from the corresponding table. In this tutorial, we are going to create a project for saving a user first name and last name as shown. Let us test. Let us say first name press, last name last, and save. And we are going to retrieve user data from room database. As shown, our app displays a list of user data. Let us start implement this project using room database. Open a new project, and the first step, add room dependencies. Here in Gradle file project lib, add plugins for room com.google.devtools.ksb version 1910-1013, and update our JetBrains Kotlin Android to 1910. In Gradle file application lib, add plugins for room com.google.devtools.ksb and add room dependencies. KSCB Android X Room Compiler 2.60 and Android X Room Runtime 2.60 and Android X Room Kotlin 2.6.0, and ensure that Java version source 17 and target Java version 17 and JVM target 17 and Kotlin compiler extension version 1.5.3 synchronize. Second step, create a new Kotlin file, call it user entry, okay, and create a composable function, call it user entry, okay. We need a modifier, and we need a column with vertical arrangement equal to arrangement spaced by 8 dB, and a modifier equal to modifier dot padding all equal 8 dB. Inside our column, we need outline text field, okay, value and on value change with default values, okay, and we need another outline text field, okay. Let us test our preview, okay. Here we have two outline text field, and we can add label for the first text field, call it first name, and for the second text field, call it last name, and also we need to add a button, name it save. As we mentioned before in a state tutorial, state in an app is any value that can change over time. Here we have two state variables, first name and last name, and by typing any word for the first name and last name, we need to update the state of the app. At this point, we are going to implement room database components, and first we will create table contains our state variables, first name and the last name. Create a new package, call it data. Create a user entity class. Define data class contains our state variable, first name, type string, and last name of type string. Add entity annotation to tell the room that this data module represents a table. By default, room use the data class name as a table name, and we can change table name by changing a table name properties in entity, use call it user, okay. And we must add a primary key IDE column that uniquely identifies each row in our table here, add a column, call it IDE, type integer, and with initial value 0, and use annotation primary key annotation. Okay, and here we have 3 columns, IDE column and the first name column and the last name column. We can change column name by adding annotation column information info, and here add a name, call it first name, and the same for the last name. Copy and paste and change to last, and set the parameter auto generate equal true, so the ROM generates an incrementing IDE for each entity. This approach guarantees that the IDE for each item is unique. At this point, we have a table user and a 3 entity fields, IDE and the first name and the last name, and each row of our table represents an entity instance. Next, define a data access object DAO interface. Here, create interface, call it user DAO. Okay, and add annotation, DAO annotation. Okay, and here we are going to define method for interacting with our database tables using insert annotation and update annotation and delete annotation for deleting and updating and inserting rows in our table, and using query annotation for writing our own SQL query. First, at insert annotation, add property on conflict property equal on conflict strategy dot ignore, using on conflict strategy dot ignore to ignore any new item in case of a conflict happens. Below insert, add a function insert that takes an instance of user entity and mark it as a suspend. And below update, define function date takes instance of user entity also suspend, and on delete suspend function delete also take user entity instance. Add query annotation. We need a function for getting all users list, call it get all user, and return flow of list of users entities. In query, add a parameter, select all from our user table and get list of our users. And next, create database class, call it user database, and using a database annotation that includes an entities array that lists all of the data entities associated with database. Here we have only one entity, user entity, and we need a database version, here version 1, and our class must be abstract and extend this room database. And for each DAO class that is associated with our database, the database class must define an abstract method that has 0 arguments and returns an instance of the DAO. Here, abstract function, user DAO, return user DAO instance. Next step, we need to initialize our database using a singleton pattern as shown in this code. You can copy this code for any application you are going to implement. At this point, we have created our own database component, user entity, user DAO, user database. Next, add a repository class, call it user repository. A repository class provides our view model with the values from local data source or remote data. But here we have only local data source, room database, and so we need a value, private value for our user DAO. And we need to define a suspend function, insert user, take user entity parameter equal user DAO dot insert user entity. Also define suspend function, call it update user, take user entity as a parameter, and equal user DAO dot our parameter. and also suspend function delete take user entity parameter and equal user now dot delete, and also we need a function get users list return a flow of list of user entities equal user DAO dot get all users. Next, create view model class. Call it user view model. Takes a parameter our user repository and extend this view model. Here we need a variable. Call it user UI state by mutable state of user end with first name empty and last name also empty private set. And we need a method for update user UI state. Take a parameter user entity. Here update our mutable state user UI state equal user entity. And we need to pass our user UI state values to user entry composable function. So here we need an instance for our view model of type user view model equal health view model, and define a variable UI state equal to view model dot user UI state. And by typing any character in text field generates a new event, and on value change function is called, and we are going to use our update user UI function from view model inside on value change function here view model dot update user UI state, passing our UI state dot copy our first name equal to it. Same for the last name on value change function. Here equal last on value change function calls update user UI state function and passes a new values for first name and last name. And here in our view model, our user UI mutable state updated with a new values. Then our view model passes this value to our user entry functions, and our text field values updated equal to UI state dot first, and the same for the second text field UI state dot last. For saving a user data in our user view model, we need to create a function, call it insert user, and using view model scope launch a new coroutine. Inside our coroutine call user repository dot insert user and pass our mutable state of user UI state. And back to our user entry composable function in our button modify on click function equal to view model and insert user function. Let us test our app. For example, let us say our first name John, last name Steven, and save. Open our app inspection. Here in our user table, we successfully inserted a new row in our database table. Let us insert another user data, call it Amy, and the last name Tom. Save, open app inspection, and refresh, and here another row. Second step, we are going to implement a composable function for displaying our stored data. Create a file, call it user list. We need a card for each user contains first and last name. Create a composable function, call it user card. And here we need a modifier and elevation equal card default dot card elevation default elevation 2.db, and we need a column using modifier dot padding 8.db and fill maximum width and vertical arrangement equal to arrangement dot space by 8.db, and we need instance of user entity, call it user. And inside our column, we are going to display user first name and user last name using text. Okay, equal user dot first using style equal material theme dot dot title medium, and same text for the last name, text equal user dot last, and with the style title medium. And we need composable function, call it user list. For displaying our users data, need a modifier and need a user list of type list of user entity using lazy column modifier equal modifier, and using items equal our user list, and for each user in our list implement user card of modifier equal modifier dot padding all equal 8 dB and user equal user. And back to our user entry. Below our buttons, call our user list function modifier equal modifier, and for user list we need to retrieve our data from database. In our view model, define a parameter user list get equal user repository dot get all list. In our user entry, define a variable user list by vmodel dot user list dot collect as a state initial values empty list. Okay, and import. And in our user list equal user list. Okay, let us run our app. As shown, our stored data list displayed in our screen. Let us add another user first and last name last, and save. Here our list updated, live updated, because we are using a flow list of user entity. Thanks for watching, and please subscribe my channel.